Good day, everyone. I am Basilio. In this video presentation, the last section of the fourth chapter of John Hospers' Introduction to Philosophical Analysis will be discussed. For the topic outline, we will be discussing a brief introduction about the author and about the book. We will mainly talk about the fourth chapter of the book, The Way the World Works, Scientific Knowledge, mainly focusing on introducing the problem of induction and solving the problem of induction. First, let's talk about John Hospers. He was born on June 9, 1918, and died on June 12, 2011 at 93 years old. He was an emeritus professor in philosophy and one of the founders of the Libertarian Party, where he was nominated to even run for presidency in the United States. Some of his famous works include, but are not limited to, The Meaning and Truth in the Arts, and the one that we will be discussing today, Introduction to Philosophical Analysis. Some of the philosophers that greatly influenced John Hospers include David Hume and Ayn Rand. The Introduction to Philosophical Analysis that we will be using is the fourth edition, which was published in 1997. Still, this book remains to be the most accessible introduction to philosophy that is available, that will be using problem-based approach to ensure that the philosophy is not simply taught to the students, but practiced by them. So for the first part of this discussion proper, let's talk about the problem of induction. Some topics that we will be diving in include inductive reasoning, inductive evidences, and David Hume's argument. So actually, the section started with explaining the differences between deductive reasoning and inductive reasoning. According to the text, deductive reasoning uses arguments that can logically deduce the conclusion from the premises. For example, if all dogs are mammals, and all mammals are living creatures, then all dogs are living creatures. On the other hand, inductive reasoning is not like that. Inductive arguments are not deductively valid, and the conclusion does not logically follow from the premises. Instead, they provide evidences to the conclusion and make it probable, but not certain. For example, if every time you let go of a stone, it has fallen, then the next time you let go of another stone, then you can consider it to probably fall again. So with this premise about the differences between the deductive reasoning and inductive reasoning, Hospers said, often, however, the fact that something has occurred repeatedly in the past is not taken as evidence that it will continue to occur in the future. So this will be further explained with the following scenarios in the given slides. So the first scenario is this. Imagine you're in preschool or elementary school, and you've been playing for the past 6 to 7 years. But then, upon reaching a certain age, maybe 12 or 13, you proceed to high school. Do you still see yourself to continue the same routine in the next 5 years? So in here, the inductive evidence says otherwise. So instead, to continue what you've been doing in the past, which is maybe playing around or going to school and other stuff, that does not serve as an evidence that it will continue to be happening in the future. Another example. In the past centuries, people uses animals to go from one place to another. So like animals for transportation. Imagine if you were there during those times. Probably you would be assuming that, okay, since this is what is happening from the past, in the future this will be continuing too. But then, the inductive evidence says otherwise, because in this scenario, with the new inventions like automobiles, buses, airplanes, and other transportation devices that are more accessible, the inductive evidence tells us that they would probably replace horses or other animals for transportation. In here, the last scenario, we have a 20-year-old that you can see is aging. Maybe let's say it's 80-year-old guy. So in here, if a 20-year-old says that, yeah, in the 20 years of his experience living, he get out of his sleep. But then there's an accumulated evidence of that with the 80-year-old guy, with the old man, because he's 4 times the age of the 20-year-old guy. But then that accumulation of evidence does not tell us that uh, that the 80-year-old guy will outlive the 20-year-old guy. In here, actually, with the application of different scientific laws, biological laws, which was explained before, we know that there's this cellular deterioration, other natural diseases that older people get compared to younger. And in here, actually, the inductive evidence will tell us that more people die of old age compared to 20-year-old. So in here, in this scenario, we can see how inductive evidence does not support that what happened in the past certainly will be happening in the future. But then let's not forget that it still gives us this probability. Actually, laws of nature was even mentioned in the text. According to Hospers' written works, maybe the way that the laws of nature are uh, are described or explained now is because of how we conceive it. That does not in any way prove that these uniformities will continue in the future, because no one can define anything into existence. Just like how we cannot say that a law will continue to operate in the far future just because that's how we define it. He even mentioned this particular statement saying that maybe there are no laws of nature in the sense we require. So with this premises, with these arguments, it was followed by the introduction of David Hume. So actually, David Hume, in his written works, A Treatise of Human Nature and An Inquiry Concerning Human Understanding, which was previously discussed, he questions the acceptability of inductive argument. He asks on what grounds we come to our beliefs about the unobserved on the basis of inductive inferences. He actually presented arguments, in the form of a dilemma, which appears to rule out the possibility of any reasoning from the premises to the conclusion of an inductive inference. So, this questioning to the acceptability of inductive reasoning was first presented by David Hume and uh, continuously being debated about even with different philosophers. Actually, we might try to get out of this impasse, by laying down a general principle that's discussed before called principle of uniformity of nature. So, just a recap, this principle states that as the laws of nature have been in the past, so they will be in the future. Okay, so we have now a principle, we have a premise, so this will work, for a conclusion. But then you need to think about this. Using this as a major premise, in proving itself or trying to establish itself is considered as a logical fallacy called begging a question. In this case, using this as a major premise is assuming something in the process of trying to prove it. But then Hume didn't stop there. He created different conundrums and dilemmas between the philosophers and in philosophy itself. But then he didn't stop there. He actually attempted to explain using customs and habit. So, but then this explanation by David Hume only gave us why we expect these uniformities and why we humans are inductive creatures, but they still did not provide justification for our inductive expectations. Then comes this next part of our discussion, solving the problem of induction. So in here, solving being a key relative term. You will get it once we finish discussing this. So first is the solution, pragmatic justification, or maybe induction is not deduction at all. So in this case, where uh, the linguistic solution, the dialogue started with a skeptic and a philosopher. So a skeptic mentions how I agree what you call evidence is commonly called evidence, but that proves nothing. In this case, or in this scenario, the skeptic will refuse to consider what the philosopher says as an evidence. So if you read through their discussions, there is no linguistic alignment on what the terminology they are using. You may be asking yourself, what is reason actually? As a term, what is evidence? So if there is this linguistic alignment between the terms that they are using, maybe that will serve as a solution to this problem. The next one is pragmatic justification. So actually, this one uh, solution for me is a cop out with the problem because this one you are not justifying the principle itself, but the adoption of it. We interpret it to the adoption of our goals and to meet those necessary goals that we are trying. So we interpret it as a kind of a rule of scientific enterprise. We justify the adoption of the uniformity of nature principle in terms of our goals, but not the entirety of the principle itself. So in here, maybe logically specifying a determined goal and not comprising all of it as entirety of the principle, we can justify the problem of induction. In here, there is this uh, term that was mentioned, which is scientific methods. So it was mentioned that it's observing data, noting apparent uniformities, discovering possible exceptions and varying conditions, devising explanatory hypotheses. So according to Hospers, this is our best bet for making future discoveries. But then there is this alignment with scientific method and inductive inference or inductive reasoning because Hospers now question scientific method because he questions is there any assurance that the situation will remain so in the future. So again, uh, their analogy here is like Hume know that humans are inductive creatures, and in here, uh, Hosper says that scientific method is primarily used to unlock different secrets of or how the way work works. But then, like Hume, Hospers in this scenario question scientific method because how there is no assurance with what what may in the future, and if there is a sudden change that we don't expect, how can we say that the best way to predict something is using scientific method? What if uh, the unscientific methods or those that are not used suddenly unlock secrets of how the world works? Then are we disregarding scientific method induction? So in here, upon reading this, there will be this alignment with scientific method and inductive reasoning. But then let me ask you a question. Is then scientific method equated with inductive inference? So after all of this discussion, maybe the answer is that induction is not deduction at all. Therefore, it's not an inferior form of deduction, and there is no general justification for induction. So this solution is actually saying that the problem is a mistake. There is actually no problem with induction because others are just trying to be unreasonable and demand for induction to fit in the box of deduction. And in the first place, it's not even deduction at all. You know, there is this statement that was mentioned that there is no point in owning a dog for not being a cat. Just like there's no point in asking the problem of induction when it is not deduction at all. But then this asks us questions like, has Hume been answered? Has anyone presented any evidence that in the 10 minutes of the course of nature will not radically change? So in here, up until now, scientists they still go on and believe that nature, with the scientific methods, will continue to work as it has in the past. Then is this just scientific faith? Didn't still continue their activities and never thought of this question. But the question has continued to fascinate and plague philosopher even today. That's all for my presentation. Thank you very much.
I'm going to discuss Acuna's Unit 4, Module 3 and 4, which is about induction and um, nature of empirical arguments. In philosophy, the term induction is ambiguous. It has many interpretations, and epistemologists use the term induction to refer to a general principle which states that events in nature are regular, not random. This means that the past, while not a carbon copy of the future, nevertheless resembles it. In induction, past experiences are used to make future predictions. This is the fountainhead of all empirical arguments, and this allows you to connect one event with one another. So, the course of nature is uniform and that the universe is governed by general laws. And you know that all experiences are about particulars without the principle. Events will be isolated, unconnected, and unrelated to from one another. And induction is from a specific statement to a general conclusion. Nature of inductive reasoning. Any type of argument which doesn't contain a reference from the observed to the unobserved or from familiar to the unfamiliar is not considered inductive reasoning. This means that in an inductive argument, what is claimed in the conclusion goes beyond the evidence found in the premises. In most cases, inductive argument must content itself with mere probability. So to appraise the logical quality of an inductive argument, we need to analyze the content and reliability of inductive inference. Given there are 100 marbles with the same size, weight, and brightness in a box, we should use random sampling so that all marbles will have an equal probability of being chosen. So case 1, drawing one marble. So your specific statement is one marble is white, and from that we can conclude a marble is white, and we can infer that a few marbles are white. Case 2, drawing 9 marbles. So there are a total of 10 white marbles, and your conclusion is there are many white marbles in the box. So your inductive inference is are most marbles white? And from that, the term most has strict use, means 50% plus 1, or the evidence of 51 white marbles. Or remember, we have a total of 100 marbles in the box. So case 3, drawing 20 more marbles. So you have 30 white marbles and all marbles are white. So your inductive inference is that all marbles are white. Although it is highly probable that all marbles are white, and with the increase of the number of samples, we have rendered a universal statement likely probable. And for our case 4, we have drawing 50 more marbles, and this gives you 80 white marbles, and your general conclusion is most marbles are white, and your inductive inference is almost all marbles are white. You know that you know now certain that most marbles are white since you have exceeded their required evidence. And case 5, drawing 10 more marbles. This gives you a total of 90 white marbles, and your general conclusion is almost all marbles are white. And from that, you can infer that the remaining marbles are all white. The statement almost all marbles are white is true beyond reasonable doubt, but this is only highly probable. However, even if there is only one marble remaining in the box, the claim that all marbles are white is true beyond reasonable doubt, but it is still not certain. In short, it is logically true, but realistically may or may not be true. Remember, we only need one counterexample to falsify as a claim or a statement. Required evidence for different levels of generalization are claims with a varying degrees of probability depending on how close our sample to the required evidence is, and the use of a few marbles are white, some or several marbles are white, are systematically vague. Their domains change depending on context. So if you have complete evidence to confirm your generalization, you have not made an inductive inference. The element of arguing from observed to the unobserved or from the familiar to the unfamiliar is missing when you have complete evidence to support a claim. Now, we have a question. Is the principle of induction useful? So try to imagine what the world would be like if you lose the ability to use the principle of induction. If you cannot use the principle, you will not be able to detect any kind of regularity, like cause and effect, chronological order, or sequence, and consequently, if you can detect regularity, will you still have the concept of past and the present? What about the future? So your study of principle of induction provides you with the foundation of dealing with all types of inductive reasoning, all reasoning from the observed to the unobserved or familiar to the unfamiliar is inductive, and most of the reasoning you will encounter in the business of living is not deductive but inductive. And many of your arguments are based on inductive, not deductive. Generalization. So this is the module 4 of Cunha's unit 4 and generalization. So it is safe to assume that we are all familiar with the term generalization. This is the most common type of reasoning. However, you may not be familiar with the requirements for making a good generalization. And we're going to discuss that in this section. So, do you believe that all crows are black? Remember that we only need one counterexample to falsify the statement. However, falsifying a statement is as difficult as verifying it, since we need to find a crow that isn't black. So, although you also know that the claim is if the claim is knowable, hence is provable. And although you know that the claim is provable in principle, but not in fact, it is probable given that you have unlimited resources to investigate in all corners of the world. So if you're going to produce the required evidence, we can settle for big terms such as many, few, or several. Remember, even if you have the unlimited resources, even if we can do something, it doesn't mean that we need to do it. So requirements of a good generalization. So the first is the observed cases or sample must be representative of the class or population. And the second is there are no conflicting case in the statement. So in the case of the all crows are black, in fact there is a white crow. You can search it in the Google. So let's discuss hasty generalization. Hasty generalization is very tempting fallacy because of our human tendency to do things the easy way and lazy, which is a single sample and without further investigation and sufficient evidence, we characterize a certain population. So the root of many, in addition, the root of many superstitious beliefs is hasty, careless, and even dishonest generalization. There are guidelines in making a generalization. Are there enough cases to support a many claim, a most claim, and almost all claim or an all claim. And second is, how have the observed cases been found in every possible variety of times, spaces, and circumstances? And the third is, has a thorough search been made for conflicting cases? So let us consider the example of Charles Darwin generalization. All white cats with blue eyes are deaf. So this generalization doesn't fully satisfy the requirements of the three tests. So, and we have not been informed about the number of the total population of white cats with blue eyes in the whole world, and we do not know how many samples were taken. And we also do not know about the varieties of time, places, and circumstances of Darwin's observation that became the basis of the universal claim. However, if Darwin can discover the causal connection between lack of pigments in a cat's fur and eyes and detect in the hearing organ, then this empirical generalization will be strengthened by the discovery of the causal connection. So philosophers of science believe that most of the so-called empirical or natural laws started as empirical generalization until the causal relation is discovered and explained. And since Darwin proved that causal connection between lack of pigments in a cat's fur and eyes causes deafness, his generalization has acquired a qualitative change. Its truth no longer requires more empirical samples for its strength. So, as we studied generalization, I hope you learned something and remember that we should have a healthy degree of skepticism and let's not accept a generalization unless we verify it or it came from a reliable source. And there are many implications and applications of this lesson, and I hope that this lesson help you to understand the inductive reasoning and generalization according to Cunha's Unit 4, Module 3 and 4. Thank you for watching.